back to the Module 4 Part 1 video. This video is on a microcontroller subject BEC405A 2022 scheme, 4th semester. So today I'll start with the Module 4 Part 1. In the Part 1 I'll be explaining about the interrupts, that is IE, and then ISR, that is Interrupt Service Provider, and steps to what it does. Then IVT, that is vector table, interrupt vector table, then enabling and disabling of the 8051 interrupts. So in the part 2 video, I'll be discussing the programming serial communication interrupts, that is RI and TI, then interrupt priority in the 8051, and also the C program using the interrupts, and then ALP using the interrupts. So this is the important things that you have to read in this module 4. So let's get started. A single microcontroller, it serves several devices in two ways. Either it does in the interrupts or the polling. Interrupts means whenever any device that needs its service, the device notifies the microcontroller by sending it an interrupt. Then the microcontroller interrupts the current execution and serves the device. So the programming is associated with the interrupt, which is called as an interrupt service provider. Polling, it is a microcontroller that continuously monitors the status of the device. When the status condition is met, it performs the service. After that, it moves on to the next device until each one is served. However, polling is not efficient use of the microcontroller. So the advantage of the interrupt is what? Microcontroller can serve many devices. Not all the same time, but based on the priority it is assigned. So polling uses a round robin fashion. Also in interrupt, a microcontroller can ignore a device request for service. ISR, it is on the for every interrupt there is an ISR or an interrupt handler. When the interrupt is invoked, microcontroller runs the ISR. For every interrupt, there is a fixed location in the memory that holds the address in ISR. The group of memories that holds the address of the ISR is called as an interrupt vector table. Then the steps for the executing an interrupt. First step is it finishes the execution. It is executing. It finishes the execution of the executing, and then it is saves the address of the next instruction in the PC of the stack. It also saves the current execution of all the interrupts internally, but not on the stack. It jumps to the fixed location in which it is based on the interrupt vector table that holds the address of the interrupt service provider. So here the microcontroller will get the address. Now what next to do? It jump to it. It will execute the interrupt in the subroutine until it reaches a function called as a return 1. So after executing this, it will return back to its place where it was interrupted, and it will finish and it will get back to the PC address from the stack by popping and the 2 bytes of data stack into the PC. So then it starts to execute from the address. We are having 6 interrupts in 8051, including the reset. So first thing, reset is the first one. ROM location is 0000, pin is 9. Flag clearing is done auto. External H/W, that is into, or you can say EX1, that is 003, P3.2 pin auto cleared. Timer 0 interrupt 1, that is THO 000B. Then here it is, flag is auto cleared. External network, that is into 1, EX2, that is 0013, pin 3.3, I3, that is cleared auto. Timer 1 interrupt, that is 001B auto cleared. Last one is the serial communication, that is RI and RT. This is 0023 where program clears it. Reset is, it is only 3 bits are reserved, that is 00, 00, 00, 01, 002. So int 0 and int 1, this is what only 8 bits are reserved for each of the IVT in both of them. In timer 0 and timer 1, 8 bits for each instruction, that is 0P to 0012 for T0 and 0013 to 0018 for T1. Serial communication 8 bytes for 0023 to 002. So in the service routine for a given instruction, it exceeds the 8 bytes of LJMP, that is long jump instruction, is placed in the vector table to point to the address ISR. So how it is done is ORG0, it wakes up LJMP main, bypass the IVT, then ORG30S, it's a wake up program, then it goes to the main, it will execute and end. Next comes the main next question, that is enabling and disabling of an interrupt. Upon the reset, all the interrupts are disabled. So the interrupt must be enabled by the software so that microcontroller responds to the interrupt. There is an register called as IE, which is an interrupt enable. This is responsible for the enabling and disabling. So it is given by 8-bit addressable EX0, ET0, ET0, EX1, ET1, ES, ET2, and let's explain. EA's first one is my enable, which is it disables all the interrupt if EA is 0. No interrupt is acknowledged. If only EA is 1, then only the individual interrupts can be enabled by clearing or settling it to enable bit. Next one is reserved for the future use. ET2, it is enables or disables the timer to overflow. Next ES, it enables or disables the serial port interrupt. ET1, it enables or disables the timer 1 overflow. ETX1, external interrupt 1, that is IT1, is enabled or disabled. ET0, it disables or enables the timer 0 overflow. ET0, external interrupt 0, enables, disables. So steps to enable an interrupt. So firstly, you have to mention this is compulsory, then only the remaining things are executed. That IE.7, that is enable, should be 1. Then only it allows to reset the IE to take the effect. If EA is 1, then the enable is interrupt is enabled and it will be responded to its corresponding bit, that is IER high. If EA is 0, no interrupts will be responded to even if the associated bit is high. So you can see an example here. If this is a given move IE, then they have given me 8-bit, that is 96H. Then the first one is what, my IE.7, that is enable, it is 1. Next one IE.4, that is 1. Then IE.2, this is my serial interrupt, this is my external interrupt, and I1, this is my timer 0 interrupt. So CLR, it is IE.1, it is mask, that is timer 0 interrupt only. CLR IE.1, it is disable all the interrupts. Alternatively, SETB, you can also write it as clear, or you can just set IE.7 or IE.4, IE.1, like that also you can write. So next is programmer timer interrupts. Programmer timer interrupts, and then we will be discussing about the next, we'll be discussing two major programs. After that, we'll go to the program serial communication. So okay, so let's start here. In polling, we have to wait until the TF is raised. While waiting, this microcontroller cannot do anything else. So using the interrupts, we can solve this. How? In the polling, the monitor JMB TF as a target is used. In the interrupt, the timer interrupt in the IE register is enabled. When TF is raised and microcontroller is interrupted, whatsoever it is doing, it jumps to the ITF to service the ISR. So in this way, we can do other things when until that TF is raised or notified. So place all the initialization codes in the memory starting at 30H in order to avoid the memory space allotted to IVT. So long jump is the first instruction where it 8051 executes. Next is ISR, that is timer 0 is located in 00BH and timer 1 is located at 001BH. It is enough to fit the address space located in this interrupt. So now configure it, set the timer, enable the interrupts, and start the timer. So finally, it will write the ISR and it will execute. Next is important program where you have to display the value of Y at P0 and value of N at P1. So generate a square wave of 10 kilohertz in the timer 0 mode 2. So this is a program. Please to refer to the comments written next to the lines and you can easily understand what is given in the program. Similarly, here you have to generate two square waves, one of the 5 kilohertz frequency in P1.3, another of the 225 kilohertz at P2.3. So here also the comments are written. It's very easy to understand once you read this. Go through the program. It's also an important program. So this completes the module 4 part 1 video. In the part 2, I'll be continuing with the serial communication interrupts. Thank you for watching. Do like, share and subscribe to Exam Ignite for the further modules.